this talk is going to be a little bit different. It's not going to be necessarily about 3D vision itself, but it's going to be about how I navigated the conference. So this entire series of events now and the next couple of days was put together by myself. I went out to the 3D Vision conference in Vancouver, where I met with Sebastian and some of the other speakers that you'll see throughout the series of events. And I needed to make sense of the research landscape there and kind of figure out, you know, what papers I should check out, who should I talk to, what I should integrate into FiftyOne, and things like that. So this is kind of more of a story about my journey for how I, you know, kind of navigated the research presented at the conference, and then also leaving you guys with a data set that you could download and kind of explore further on your own, so that you can kind of see what research was there and you know how to navigate that research. So the conference itself was an interesting conference. A lot of great research presented. There was just one track. It was a single track conference, probably the smallest conference I've been to. You know, if you've been to CVPR or NeurIPS, this was orders of magnitude smaller. You know, there's only about 100 and I think 70 something papers accepted. And it was one track, single room event, and one kind of poster hall, but still a lot of really good research that was presented. So I want to talk about how I went about kind of getting an understanding of the research landscape at this conference. So the problem here is, you know, if we're given like the conference schedule, right? Even if you're given the conference schedule, it's kind of hard to figure out exactly what is of interest to you or what you want to check out. Of course, there's you know, abstracts that you can read through, but even that doesn't give you the full picture of what's happening at a conference, much less give you an opportunity to kind of, or the ability to easily kind of connect different papers together in different kind of clusters of research. So of course, one way to do that is you could download papers individually, click through papers and kind of read through them one at a time, and maybe come up with some way to manage, you know, this body of knowledge somehow. Maybe you find some way to organize them into different buckets and into, you know, organize them into papers that you want to read first or not read first. So you know, this is one way to do it, just clicking through a file system, opening papers individually and doing that. I took a different approach. What I did was I started off with those papers just like this, and I converted each one of the pages of the paper into a FiftyOne data set like so. And what I do with this FiftyOne data set is some analysis using vision language models and some visual document retrieval models to kind of help understand the landscape of research being presented at the 3D Vision conference. So what you end up with here is actually kind of an interactive data set where everything's right in front of you. So already a step above this kind of pattern where you have to click around individually to see what's in each individual paper. You have everything all at once right in front of you. So what we're looking at here, this is you know, using the open source library FiftyOne, just pip install FiftyOne. We'll drop a link to the GitHub here. But what I've done is I've created a FiftyOne data set. So a data set is essentially just a ordered collection of samples. And each one of these papers is a sample, which just represents some type of media. That media could be an image, it could be video, it could be point clouds, it could be some combination of those. And each one of these samples has fields associated with it. As you can see here, these are all fields. And what we're able to do now is quickly go through your you know, visual data set and really explore what's in there without having to click through and look at stuff on a file by file basis. And so this is what we call a grouped data set in FiftyOne terms. So each PDF that I had, I converted each page of the PDF to a image. And what I end up with is a total of about 3,020 images across 176 papers. and created a group data set where we're grouping papers by whether they belong to the same paper, and each one of these has a slice. So the term we're using here is a group slice. So each slice of the paper is a page of that paper, right? So just kind of give you a high-level overview for what it is that we're working with. I'm not sure what I just did, but I'll have to refresh this. So we end up with this FiftyOne data set here. And of course, the demo gods are not smiling on me. We end up with a FiftyOne data set that we're able to just quickly explore. And the way I do this exploration is using vision language models, specifically Qwen 3.5, which you'll see in a second here, and using a document embedding model called Jina v4. And this is going to help us kind of make sense of the research that is presented at this conference. We're doing a lot of analysis using something called the FiftyOne Brain, which is just, again, is open source, and it's just a set of routines that allow us to do some interesting things with embeddings. And we'll have this really cool interactive data set, as you've seen here. And I'll go ahead and make sure that figure out what's going on here. Of course, what happens is, demo gods sometimes do not smile upon me. Looks like I accidentally closed out that session here. And then we'll go ahead and open it back up. We'll let that load. By the way, this data set that I've just shown you, it is already available here on Hugging Face. I'll send you a link here in a second. It's right here. I'll go ahead and drop a link to the paper. All right. So picking back up where we left off, we've got a data set loaded into FiftyOne format, created a group data set, and now what we want to do is do some interesting analysis. So what I ended up doing was I used a vision language model to kind of understand these papers at scale, right? Reading 177 abstract is kind of feasible, of course, but reading 177 abstract and then making kind of a decision about what paper to prioritize across the multiple poster sessions and oral slots, and coming up with a schedule, doing that, it's a bit challenging, at least for me. And so what I did was I used Qwen 3.5 VL, and I created a couple of supplementary fields for the data set that I have at hand. Specifically, I did something for classification of the topics. So I did a topic classification, which is going to be here, the topic classification. Whether this introduced a kind of new data set, whether it introduced a new model, benchmark, method, and also extracting out who the authors were that authored the paper, as well as the different affiliations of the authors. So what I want to start off by showing you here is the different ways that we can slice and dice this right off the bat. So what I'm going to do is open up a dashboard here. You can see that I've got the topic classification here already. In addition to the topic classification, I've got fields such as whether it introduces a data set, introduces a model, introduces a method, benchmark, and so on. Now, having used a vision language model, I essentially asked Qwen to read the first page. I prompted it to read the first page and tell me what you think this paper belongs into. And I gave it a list of 10 different topics that it should choose from. And specifically, the prompt I gave it was this right here. So I prompted the model real quickly to pick from one of these topics and see how it could bucket a particular paper. And using this was quite straightforward in FiftyOne. I'll drop a link to the GitHub repo here, but it's essentially just registering the zoo model source, downloading and instantiating the model, and then you know, assigning any model generation parameters you need. And then from here, it was putting it into operation of classification mode, and then defining the prompt. And then from there, just applying the model. So real quick and easy to get started. Once you do that, you can do some interesting things here, like creating a histogram. So I'm going to create a histogram here, specifically using the labels for topic classification. You can sort it by frequency. And already this gives me a one step better navigation because I could click in on any one of these bars here and kind of look for papers that are in that category as assigned by Quint 3.5. So already it's a step above where we just were here, which is clicking through each one of these things individually. So we're getting one step better at understanding the different research that was presented at this conference. Now, another thing we want to be able to do is, at least for me, like a lot of the value I get from going to a conference is, of course, getting up to speed on research, but also interacting with different researchers that are, potentially could, be a speaker at a virtual event of mine. And so I also asked the model to extract a few interesting fields for me. One of them is the affiliation. So essentially the list of schools that or institutions that this paper is associated with, as well as the name of the authors as well. And so we could add all this to the actual dashboard as well. Create a categorical histogram here. We can say whether this paper introduces a data set, whether this paper introduces a new model. And all this information, of course, is interesting to me because I want to be able to figure out what I would potentially include into 51, whether it's integrating a model or integrating a data set. So you can easily create these type of dashboards here that are all interactive. For example, let's say I'm interested in papers about 3D generation and editing. You'll see the dashboards update automatically. Of course, I only want to be interested in papers that might have a data set or might have a model associated with it. And so we can drill down further like so. So it gives us a step above where we were with trying to understand the research that was presented at this conference. So all this is good and helpful, but it doesn't really give you a way to really, connect the different papers to each other. And so for this, we could take it one step further and look at using embeddings. And what I did was used a model called Jina v4, which is a model that's for visual document retrieval. Really nice model, lightweight, quick, and has some very good performance. And what I did was I used this model to compute embeddings on this visual document level, computing embeddings for not only the first page, but then also every single page in a paper. And there's a couple of things that I had to do. One was having the having the data set as a group data set. I converted it to a flattened data set where each and every page in that paper gets its own sample in the data set. I then use the Jina v4 model to compute embeddings for each and every single page, and then aggregated those embeddings using mean pooling to get a single vector representation of the entire paper. So I did that with the flattened view, and then also just strictly computing the embeddings for just the first page of a paper itself. And what we're able to do now is actually explore the papers in a more interesting way. So starting with just the embeddings for the paper, first page of the paper itself. We can open up the embeddings panel here, and we can start to see which papers form clusters based on just the first page. So that's what I want to turn our attention to here. For example, I could go down into here, maybe drill into this group of papers, right? So it's interesting to note here that, okay, this group of papers, this yellow tag you see here of the topic classification, we came up with this topic classification using Quen 3.5, the VLM Quen 3.5, and giving it a prompt and asking it to classify what it thinks these papers are, the topic of these papers. But when I use a different model, Jina V4 embeddings model, we see that, these papers that Quen classified as all being the same are actually very close in this embedding space. So we see a little bit of, correspondence, if you would, between what the Quen model thought was the topic and based on just the semantics of the embeddings itself. So I thought that was a bit interesting there. So we're able to drill in here and look at papers that are the same, just strictly looking at the first page of the paper. If we look at the flattened view, we end up with some interesting structure here. So remember with the flattened view here, what I'm looking at when I do this flattened view is the embeddings for each and every single page, right? So if I go here and I highlight this island of papers, I see that, okay, well, these papers are actually, these pages are actually all kind of reference pages, which is interesting. If we drill down here, we see that, okay, all of these individual pages all actually belong to the same paper. So I thought that was interesting to see when exploring the papers, was the fact that, okay, when we look at the embeddings for each individual page, those pages themselves end up forming clusters. So quite interesting to see that happen. With these embeddings, we could also do some other interesting things using FiftyOne. So going back to the slides here, talked about extracting the author affiliation using Quen 3.5 VL, and I'll link to this notebook that has all this code. We also talked about how we could tag the contribution of each paper, whether it's a dataset, model, method, benchmark, but just looking at the actual workflow with the embeddings itself. One of the things we could do is build a similarity index, right? So when we have a similarity index built, if we look at just looking at similarities, we could do it based on the actual vector representation of that image itself, but also using natural language search. So what I want to do is just show real quick how we can use FiftyOne and this Jina model to do some quick search. For example, I might have been looking through a paper and looking through this corpus of papers, I can't remember exactly where it was that I saw this figure, but it was a figure of 3D bears and dogs, right? For example, well, I could do a similarity search right there from within the app. I'll have to load the model in the background and pull it up, and we see, okay, here's that paper that had the actual 3D dogs and bears and whatnot. So this is useful, of course, when you want to see if there might be some topic dealing with, 3D reconstruction and lighting. And let's say I want to find the top 10 papers related to that. And so it gives us another way to explore the papers and kind of figure out if there's anything interesting to our specific use case. So this gives us another vector, another way for us to explore the papers and kind of figure out what the research landscape is like. Of course, we can also, let's say if we're looking at the flattened view, we're able to open any given page. Let's say I'm interested in this page. Well, I could just search by similarity using just that embeddings for in this case, the single page vector embeddings. So we should actually do something like that as well. Here, uses the individual page embeddings and do all that as well. So of course, this gives us a great way for us to figure out what's being presented at the actual conference. And I just want to go through real quick how I used this data set and this method to help me find and integrate some really interesting research from the conference into FiftyOne. So I just want to highlight a few interesting papers that I came across while I was looking through the research at this conference. Also going to drop a link here to these implementations in FiftyOne to use the models that we just showed, Quen 3, as well as Jina v4. So this first paper that I came across while I was looking through the data set I just showed you was called Spatial LM. So this data set was something about 19,900 something samples of indoor room point clouds with kind of this really interesting 3D structured layout. And then as you'll see here, just really good object annotations. And so it had a bunch of different room types across, I think, something like 60 object categories, really realistic point clouds, and really interesting architectural layouts that were very realistic as well. And this data set was designed for structured modeling tasks. So specifically use cases that had to do with object detection in 3D spaces, spatial reasoning, indoor scene understanding, and things like that. And so I found this to be interesting because it helps kind of bridge that gap between 2D vision and 3D spatial understanding. So this makes it a really good data set for training models that need to understand indoor environments. Another interesting data set was actually a benchmark. It's called Edit 3D Bench. And so this was a benchmark that was used for evaluating 3D editing methods. It had something like 300 samples from about 100 different high quality 3D models. So it combined edits from Google scanned objects and part object versus tiny. And then each sample has, as you'll see here, has prompts associated with it. The editing prompts, the region it should edit, the reference images, and then also a video rendering. And so for this benchmark, the metrics that they came up with were called preservation of unedited regions, overall 3D quality, and then adherence to editing conditions. And so this was interesting to me because it was like the first comprehensive benchmark for 3D editing tasks, which I hadn't seen anything like that before. This data set is called Palm, and I like this data set. I found it to be actually quite a handy data set. And you'll see this data set, it's quite a large scale data set. I took just 1,000 samples for the data set. And even then it was like something like 90,000 high resolution multi-view RGB images, plus the hand scans and all that. And as you see here, this is multiple modalities. We've got the RGB images, we've got depth maps, as well as a 3D mesh. So different modalities here. Had a lot of different demographics, of course, represented in there. High resolution images in a highly controlled environment. So this is useful for if you're doing things like hand pose estimation or physically based rendering or like hand shape modeling. Limitation of this, actually, every single hand they have is only a right hand. And key feature of it being in a controlled environment is also a limitation that these aren't really hands in the wild. They're like in really controlled environments. And this is interesting because like hands are very difficult for vision models. And so this gives us a really unprecedented scale for a data set like this, as well as the different modalities. Another data set I came across was called Harmony 4D. This was a multi-view data set. As you can see here in the video, there's, I think, something like 20 synchronous GoPro cameras that are surrounding two participants. And there's various activities that are depicted in this data set. There's wrestling and dancing, and all of them only have two individuals. And it's a hard problem to solve, right? Very hard problem for pose estimation. And you can see there's heavy occlusion as well. And it's a really rich data set. You get 20 cameras, each is a different view, so multi-view scenes in every one of these samples. This data set I found interesting. It's called Toon 3D. So this is 12 multi-view cartoon scenes. And this is just, I thought it was just a bit funny to try to turn cartoons into a navigable scene. But we have between 5 and 12 frames per scene with actually geometrically kind of inconsistent viewpoints. And then they also have camera poses and, as you can see here, 3D point clouds. And a good use case for this is 3D reconstruction when you have like non-photorealistic imagery. And also, of course, novel view synthesis for cartoons. And this is interesting, and because cartoons, they violate 3D consistency assumptions because they're cartoons. So this data set is just challenging models to reconstruct 3D from artistically inconsistent drawings. Another data set here is actually called Reflector. So this one has 16 photorealistic Blender interior scenes, and they're rendered from both real and virtual camera perspectives. The ground truth point clouds are included, and what it's trying to do is exploit the mirror reflections for stereo vision. So you'd use a model a data set like this, rather, it's a benchmark for benchmarking 3D reconstruction methods when there is a reflection involved. So it's a very clever use of mirrors that enable the stereo reconstruction from a single camera, and then it's turning these reflections into a challenge. Another data set here is actually from a speaker that you'll hear from, I believe, on Thursday, Michael Fisher.
It's 12:30.
Data set here is called SAMA. It's a material-centric video data set. So it has it's a synthetic video data set with 500 samples. And as you'll learn in his paper, it's for material-aware 3D selection and segmentation. So we'll be hearing from Michael on Thursday. But it has dense per-frame segmentation annotations. It produces, you could use this for procedurally generated 3D objects, various camera trajectories. It's got, you can see here some materials that are transparent. And it's just the first data set I've seen that focuses on kind of material properties for segmentation. So it's trying to get a model to understand not just what, but what is this thing made of? So all of these data sets are available here. The ones that I've chatted about, I'll drop a link here into the chat. All of them are here. I also came across this interesting model here from the conference called Online Video Depth Anything. So this gives temporally consistent monocular depth estimation, but with very low VRAM requirements. So very quick for inference and very low VRAM requirements. We'll also be hearing from the author of this paper, I believe tomorrow. His name is actually also Sebastian. I'll drop a link to this implementation here if you're interested in checking that out. So this, yeah, online video depth editing, really good for depth estimation for long videos, real-time depth processing, and it helps bring this temporal consistency while being memory efficient. So you can see here they're high quality depth estimation, and it's meant to run for longer video and on lower end hardware, and even on kind of edge devices as well. Finally, if you're interested in all of the research that was presented at 3D Vision, I've created this repository here, which links out to the data set I just showed you. And I used this data set to create this repository. So everything here, is based off of the data set I just showed you. So you can check this out if you want to see all the research that was presented at this conference. So that being said, I'll go ahead and see if there's any questions in the Q&A widget. Is there some way to have it discover relevant categories instead of having to predefine them? Yeah, I guess, one thing you could do is just do some unsupervised clustering and maybe just see what naturally emerges. And we see that in a sense with the embeddings that we create here. The embeddings are the Jina viz, right? And we can see what kind of clusters naturally form, but then again, we'd have to go through and tag those samples and assign it to a category itself. Yeah, I think, just the workflow I was doing was just assigning it to a actual predefined category. So just easier to do. Can it discover relevant categories? Yeah, I think one thing we could do, for example, is do this kind of workflow where we have computed the embeddings, maybe assign a cluster based on, whatever method you choose, maybe HDB scan, and then send batches to the model and ask the model to read maybe just the abstract or the first page, and then based on what the model reads, just assign a topic to it. So maybe that could be some workflow. And you could do all of that within FiftyOne as well. We have a plugin for clustering. Once you've clustered the image and assigned it a cluster, then you take views and then pass each view to that Quen model to do that generation. So yeah, you can definitely do that. What was my favorite paper from the conference? Well, I don't have a single favorite paper. I rather have 12 favorite papers. And these 12 favorite papers are everybody that you see chatting here. So if I couldn't pick just one, but I picked about 12. So these are the favorite papers that I've got. So you're seeing my favorite papers. Cool. All right, so that's it for me. Apologies on that bit of a technical difficulty there. It kind of messed up my flow a little bit. So hopefully you guys did still find the talk enjoyable. That being said, if there are questions, I'm happy to answer them in the chat or in the Q&A widget.